Hello everyone, I'm Xiao Gang. Okay, in this lesson, we'll work on the two small assignments from last class. The first one is relatively simple. You're currently attached to an actor. Move this actor, meaning you give it a movement distance of +1 per frame in tick. Then the actor will move, creating a dynamic effect. This is quite simple, so we won't do it. We'll mainly work on these two together, so it's like using a numeric variable to store it. Then we'll rewrite it. We can make this thing no longer require us to manually specify the camera in the scene. Instead, let it automatically iterate through all cameras in the scene to switch between them. And secondly, we will no longer use an actor pointer to store the camera. We'll use a struct. This way, we can specify different blend times for different cameras. Okay, let's go back to our project. Similarly, we might need to paste this level. We'll still use this observation. Then before we start, let's paste it first. Okay, then let's name it modify. Keep it simple. Then we enter this level. We need to delete our second card. Otherwise, it might cause some conflicts later. Similarly, we also add a C++ class here. Same as X. Okay, let's change it. Then we put it in the same position. Then we call it CameraDirector. Then modify. Let's add an XT. Okay, now let's create it. Then let's wait a moment. We'll do both assignments together for everyone. This will ramp up the difficulty a bit. Don't worry, our course has enough intensity. The intensity of our course picks up after chapter 10 and after chapter 15. It should all be high intensity lessons. For the first 4 chapters, we can only go through things slowly and casually. Good. So we can sync it over as well. Good. This part hasn't synced over yet. Check it. This place doesn't have an override, right? Then let's refresh it. Let's do it this way. Maybe I clicked the wrong thing just now. It didn't override. This is a bit troublesome. Reopen it. Okay, now it's there. So obviously, we need to change this to an array. At the same time, use a struct to describe it. So how do we do it? We define a struct here, still a struct. This struct, we can make it reflect to the blueprint, or we don't need to. Let's not reflect to the blueprint. Don't make it too complicated. Let's call it camera. Big tall. It's an info for switching this camera. Let's do it this way. Pay attention. We need to wrap this reflection red. So obviously, here we need to... I personally like to type out this public, but you don't have to. Because its default access is public, then we need to touch this. I drag it over. We do it like this. Add a pointer to it like this. Then here I set it to manual. Set it as an empty one. Then similarly, we give it a floating point value here. To set the blend time, we call it camera blend time. We give it 1 second. 一点点nip. Now we have a struct. This struct can be used internally for us to perform a calculation. So obviously here we no longer need to expose this because we need to bump into the wind. We don't need the user when using our class to care about how the calculation is done inside. They just need to use it knowing that after using this class, they can complete the scene and just traverse all the cameras in the scene to display them. So I need a TOA here. And its type is definite, dead. And similarly, we'll call it cameras list. We'll call it cameras info list. This name is well chosen, simple, and bright. Okay. So similarly, we no longer need to set this rotation time because we write the blend time. Let's just hardcode the rotation time. Like this, paste the rotation time over here. This rotation time can actually be configured. Then let's write it here. Let's still make it rotate every 2 seconds. Alright. So after we do this, let's still look here. We need to do some work in tick. So we need to do some work in BeginPlay. Let's switch it over here. Let's fix it in place. Then, to save time, to save myself from typing code, I'm afraid I'll make a typo. So I'll just paste this directly, paste it into our blueprint. The header file for the wonderful function library. If you have Writer, it can auto-import, so it shouldn't be a big problem. Then in BeginPlay, we need to complete the initialization of this entire tool, because BeginPlay is only triggered in the game when entering the scene. After the game starts running, it will execute. We really want to execute this one. Then we call GetActor. Let's take a look. No prompt. GetActor of class. It should be GetActor of class. Then let's pay attention. It needs to pass a world context. Obviously, we pass these. Then it needs to pass a top class. Have something like that. We should be able to pass this out. That is it, right? We didn't find it just now, but you can see that's him. CameraActor is camera viewport and can be placed. So the Neville is the thing we just threw in the observation. You will find it has a scene component, it has a camera component, and then some other enumeration parameters, some indices and such. And it inherits from actor. So in this case, we need to pass a ucast type. We'll just give it a scabicast. Let's take a look. This is because B didn't include its header. You can do this if you don't have a radar, because it's an engine class camera. It's right here. We actually just need to stick it over here. Because we have already emphasized the class, it is included by default. So you only need to type camera. CameraDirector is fine. So it should be written like this. This technique is something everyone should master when learning UE. Regarding how to handle information between header files and modules, this should be fine now. So let's look at what the first parameter is. For the third parameter, we can click in and take a look. We just need to look at its. Let's take a look at its. Find all actors of the specified class in the scene. And this is a very slow operation. Right. Be very careful and don't use it every frame, because it will iterate through all the actors in the scene. It must master specify restore always, as should this host. You need to be careful to clear it. Just pass an empty container into it. This is an output. It will fill the data into it for you. It's very simple. Here we will prepare a host for it. Right here. We'll let it my hammer actors. So all of my object displays of ours. He will then inject this thing, that is fill it in. You can take a look. How does he do it? This function. This part does some real-time optimization. He first clears your number, because he is afraid that the data you pass in might be unreliable. This is a very good practice. That is, we want to exclude from your interface the strange data passed in from the original call. Then this add must exist. You cannot pass in an empty one. You upload an empty one. Then we won't be able to do it. We don't even know what you're looking for. Then he got this Word document. Then in the Word document, he created an actor iterator. Then iterate through all the objects inside. Then go to this place to make a judgment, right? It's just this kind of operation. After the judgment is done, copy this thing to your pointer. Just copy it to. Then we already have an actor here. Then next we need to go deinitialize our carry info. Then our carry info, we also learned it. We also empty it. But actually this is definitely empty. So let's still empty it to avoid some other issues. This thing. Yes, that's right. Actually it should. Give it a visible anywhere. Don't let you modify it. Yes, this thing that won't let you modify it anymore. This can only be hard-coded from our C++ side. Then after clearing, we go to traverse our GS. So here we have this kind of normal traversal. And actually we can also do one more thing here. We can make a check. What does this mean? We will, in the next chapter, or the chapter after next, explain to you that its quantity must be greater than 0. Greater than 2, I think is best. At least greater than 1, because only when it is greater than 1. Does this thing make sense? If it is not greater than 1, we will let it here. Breakpoint, crash. You don't want it to crash. You can also use this number. Yes, like this. Okay, this place must be true. Then when iterating through the loop, we can get this actor. Then we get this array here. Actually, we can simply use what we learned in the previous 2 chapters. Here we added an add default gateway force. We added this and got its reference. Then we changed the values inside. Here we can change it like this. Here we are doing a simple switch. I use a lot of pasting here. I think it would be a bit slow if I typed it all out manually. Then here we set this parauto1 to equal. That is, the camera here equals this number. We retrieve this object. Then let's think about how we should do this part. Just pass I in. Actually write intersense2 here. Okay, let's change the name to index. This looks better. Okay, after writing this, we still have to assign a value, right? Actually, we can either assign this value or not. This is a time. We can make it a random time. We can make it such a time. We give it a 0 to f. This blend time is actually a bit too long. We set this time equal to plus equals index divided by 0 done tick divided by 4. That is this part 4.f. Yes. So if I have 4 cameras, the blend time for the fourth camera is 1.2. This is just written casually, just to give everyone a sensory split. It is a bit large. Then that's it. Okay, so in this way, we have finished speeding up our information. Then we execute our operation in tick. Actually, right here, we just copy the code over. And then we just replace it. And then again, like this. Okay, this time we'll still have the timer run in 2.0 mode. So the time is no longer needed. Because we've already specified it. Still, we haven't declared the variable lx change. So let's copy that declaration over. This is a time-related process. Okay, no issues here. After reaching this time, we execute this operation. Then, for this piece of code, we need to make a simple transformation. Obviously, we may need to create an index here. Because we are not sure what the current number of cameras is. So here we provide an Intel 312 CameraIndex. That is the camera we are currently using. We set it equal to -1. During initialization, there is no issue here. We set it equal to 0, which means we are now using the first camera. Obviously, when we get to this point, after we directly perform this operation, we will just proceed here. We use increment. We increment it by 1. Okay. But we might also need to check. That is, if camera index is greater than this, because its index is greater than the camera info contained in this array. We might need to do a simple handling. If it is greater than -1, that means it has exceeded the maximum index. We can just set it to 0, equal to this maximum index. There is no problem at all. This part is to ensure our index. In fact, these can all be extracted into individual methods. We haven't extracted them here. We'll extract them later, because it's just a very simple case. A function should not exceed 100 lines. Do not let a single function exceed 100 lines. Generally exceeding 100 lines is unreasonable, because it becomes harder to read the context. Then here, we need to get the local and put it here. Here we first process this camera. Then we can just switch directly here. We get the local actor. We need to pass in the camera, so before we pass it, we first need to check if this camera exists. Here we get this index. Then here the camera must also exist. It must exist, and then our camera actor must also exist. If both of these exist, we just switch the camera over. Actually, the way it's written here doesn't look very good. You can write it like this, just to make it look better for you. For this place we store, for this time we are, to ensure your readability is better. So we let it write a bit more, less camera. It should be called less camera. Just wait for it. I think I've already explained it quite briefly. If you follow along, there should be no problem at all. And here, the first variable of this ship here is that we need to use this less camera. We'll just use it directly. As for this blend time, we can directly read it from this place. We can write this time out. As for this time, we can access the struct inside like this. Why must we check here? Because you might have destroyed it. Yes, it's that simple. Well, actually we are done here. Now we can launch it and see the result. Let's just click launch like this. Why is it that this part can still be improved? You might need to update your host later. You can extract this part. Extract a method called update new colors. Update the camera information in the scene. When you encounter a situation where this actor is null, then you can handle it. Okay, obviously here, this actor, actually we don't really need it, because we can switch to it. We will never switch to this actor. Pay attention. Let's attach the camera here. Hold down Alt. Let's attach another one. Okay. Then let's switch. Let's attach another. Let's rotate its view again. Let's add one more. Okay. We didn't really pay much attention to this part. Good. Now we just need to drop our CAS into it. It should be here. Let's drop it in. We'll just drop a C++1 in. Watch closely. You're not allowed to change this part. Do you see that? Let's execute it. Whoa. It can be seen. It should be fine. Let me take a look. We can debug to check. I haven't looked into this part deeply either. There's nothing here. Could there be any issues? So let's debug and check. We only debug when switching on this side. Just turn this off. Then we dog. When the game initializes, it finds the camera and the scene through this class. Obviously, it has 5 cameras. No problem at all. Then after clearing it, we ensure it equals 1, greater than 1. Then it's fine. Yeah, we take the time within this host. We perform an initialization. Blend time. Then their blend time. Once is 1t 0.4 0.0. That's roughly what it means. The blend time increases each time. That's roughly the situation. On the first tick, after we enter, we increment the index, right? Actually, there is a problem here. It doesn't seem to check this. Should check if the camera is missing. We'll just ignore this. Okay, we'll end the demonstration of this case here. I haven't done an in-depth study of this camera. Whether it has all switched, it looks like there is a camera, but we won't worry about this issue. We'll just demonstrate how this tool extracts and modularizes it. And actually now I am going to switch to another scene, switch to another map. So I am at this location. I will do a simple deletion of this camera. Now there are 4 cameras. Let's look at it. Oh, this breakpoint is okay. Actually, these 4 cameras can also be switched. It seems one camera is missing. Let me think about this camera. 1 1 2 3 4 0 1 23 0. Okay, then it should be fine. It's just 4 cameras. Note that this camera will not be switched into. Okay, alright. So that's all for now. Just one last thing. That is, if you while the game is running, delete this camera, it will be skipped. But actually at this point, you should update the information of the scene camera. That is, re-update the BeginPlay thing. And then because at this point, if you add a camera, then the new dynamically added camera, actually, this new camera hasn't been micro-retrieved yet. You must re-execute this method. Okay, that's about it.